Moving on to question 2.7. A car is stopped at a traffic light. It then travels along a straight road, and again we're given a position function in parametric form and given values for our coefficients, b and c. So the first thing I'll go ahead and do before I even read the rest of the question is to rewrite this with those coefficients substituted. So I'll have x of t is equal to 2.40 meters per second squared times the square of t minus 0.120 meters per second cubed multiplied by the cube of t. So I want to calculate again the average velocity of the car for the time interval from t equals 0 to t equals 10 seconds. So this is the same process we just followed in question 2.6. So my definition for average velocity is change in position over change in time. The understanding for that is x of t2 minus x of t1 all over t2 minus t1. In this case, t1 will be 0, which is convenient, and t2 will be 10 seconds. So going on to substitution, this works to be 2.4. So we just did the same units in our previous example. So if you need to work with your units, please go up to question 2.6. So 2.4 times the square of t2, which is 10, minus 0.12 multiplied by the cube of t2, which is again 10. So this is my x of t2 expression. My x of t1, again substituting zeros, gives me just a 0 for both terms, all over the difference in my time, so that's 10 minus 0 seconds. So my average velocity for this time interval will simply be, one step at a time here, 2.4 times the square of 10 is going to be 240, minus 0.12 times the cube of 10 is going to be 120, all over 10. My average velocity should work out to be 12 meters per second. So at this point, you're likely bored to tears for average velocity. So let's move on to part B, which is calculating an instantaneous velocity at 3 different times, 0, 5 seconds, and 10 seconds. So instantaneous velocity. I need to recall that if my position function, which I rewrote up here as 2.4 meters per second squared multiplied by t squared, minus 0.12 meters per second cubed multiplied by the cube of time. If this is my position function, my velocity function, my instantaneous velocity in the x direction, will be the first derivative of position with respect to time. So I'm going to take the time derivative, d dt, of my position function x of t. So how does this work? Well, I'm going to take the power of t, 2. I'm going to multiply my coefficient by 2. So 2.40 will be multiplied by 2. Same units, meters per second squared. And I'm going to reduce the power of my t variable by 1. So that becomes just t. For my second term, I'm going to take my power and multiply my coefficient by that power. So my 0.12 will be multiplied by 3. Same units, meters per second cubed, and I will reduce the power of my t variable again by 1, so that becomes t squared. So my Vx function will be 4.80 meters per second squared multiplied by t minus 0.360 meters per second cubed multiplied by t squared. So I'm simply finding the instantaneous velocity at 3 times. So firstly, I'll do Vx of 0. I can see that if I plug in a 0 for both of these t's, I will have absolutely 0 velocity in the x direction. At 5 seconds, however, I need to do some substitution. So I have 4.80 meters per second squared multiplied by 5 seconds minus 0.360 meters per second cubed multiplied by 5 seconds squared. So at 5 seconds, my instantaneous velocity will be 4.8 times 5 minus 0.36 times the square of 5, which is 25. My instantaneous velocity should work out to be 15 meters per second. Go ahead and box my answers as I go here. Finally, at 10 seconds, all I need to do is substitute 10 for my time again. And that works out to be, in this case, 4.80. I will leave units off as we just dealt with units. 4.80 multiplied by 10, subtract 0.36 multiplied by 10 squared. And so my x velocity at 10 seconds will be 48 minus 36, which is positive 12 meters per second. So you can see my instantaneous velocity as opposed to my average velocity depends solely on the time derivative of my position function. Now, quick reminder, part C says how long after starting from rest is the car again at rest? So, in order to do this, I'm going to use my velocity function here. So I can see that this velocity function is a quadratic equation. And so that means that there should be two horizontal intercepts, or two x-intercepts, or time intercepts in this case. So if my velocity function is 4.8 t minus 0.36 t squared, I simply need to find both zeros for this function. So one of those is simple. I'm simply going to factor out a t from this, and I will have 4.8 minus 0.36 t. And so to solve for my two roots, I see that one of them is very obviously t equals 0. I already found that. I found that the velocity is 0 at 0 seconds. The second one comes from this part. So if I set this set of parentheses equal to 0 and solve for t, I see that I will have 4.8 divided by 0.36. So the second time for which my velocity will be equal to 0 should be 4.8 divided by 0.36, which is at a time of 13.3. And if you want to say repeating seconds, go for it. So this is part C.